Let's talk about biological materials in a circular economy. That's the left side of the Ellen MacArthur butterfly diagram. Basically, this is how nature works and how we can mimic nature in our products. Everything will eventually regrow because they're biological things. So it's the left side. And what are biological materials? Food, of course we understand, wood, bamboo, and smaller things like mushrooms, insects, and bacteria, and even poo. They're all biological materials. And as we know, we're making circles. You understand there will be food. We eat it, we make poo. The poo, we become fertile soil. We make plants, and those plants will become our food. That's basically how a biological circle works. What ingredients do biological materials need? All biological materials, I think, need water to grow. They need space, they need nutrition, they need sunshine, they eat or give carbon dioxide. We need time and some processing, some caring of them. Those are renewable resources, basically. But we need to provide them in the right amount, under the right conditions, and giving them enough time. Time is a resource in this example, of course. And we always think about food and wood, about biological materials. Actually, the smaller parts are definitely an equal size in the circle to make the circle go round. And the renewables, sun, wind, air, water, are important ingredients to make them regrow. Now we understand that some biological materials, some foods, have a bigger impact than some other foods. You probably already heard that cow meat is extremely resource intensive. And vegetarians, they have a much smaller footprint on the planet because that requires much less resources. Those renewable resources have their capacity. We are with so many people on the planet, so you should use as least amount of space, time, fresh water, and energy to grow what you're eating. This is a diagram. You can look into it. Let's talk about apples. Apples, technically, plants absorb carbon dioxide, but in the processing of making them, transporting them, preparing them, they will produce a little bit of carbon dioxide. For 3.5 kilogram or 20 apples, we make about 1 kilogram of carbon dioxide equivalent. What else can you do with 1 kilogram of carbon dioxide equivalent? 0.4 kilogram of beef. So that's a factor of almost 100 times. You can have 100 times more apples than beef. Similar numbers are valid for 1,000 liters of water. With 1,000 liters of water, you can grow 2.5 kilogram of apples, 14, or 0.06 kilogram of beef. How much energy does it take to grow an apple? For 1 kilowatt hour, you can grow 2 apples, or 0.28 kilogram. But that will be 0.01 kilogram of beef with the same amount of energy. You can also imagine that the space needed for an apple to grow is much, much smaller than the space needed for a cow to walk around. How to imagine that? Because it's not actually the space the cow needs to walk around, it's also the space the cow needs to grow its food. We grow food for the cow, and that needs to be transported and brought there. So it's not just the cow, the efficiency of the meat and the bones we cannot eat. It's also the efficiency of the kilograms of food that goes in the cow, the waste it makes, and the valuable meat it makes. The proportions are far from each other. This diagram shows a quick glance amount of resources for each piece of food you need.